Now let's take a look at finding the derivative of a rational function. This one's going to require a little bit more work, but let's work through it. We want to start off by finding the derivative. So to find f prime of x, we know that the derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So if I want to find f of x plus h, that means I'm going to take my function and replace the x's with x plus h. So I'm going to have 1 minus x plus h all over 2 plus x plus h. So there's my f of x plus h minus f of x, so 1 minus x all over 2 plus x. And then we want to divide the subtraction of these two functions by h. So now we want to simplify down this complex fraction. In order to do that, let's take those parentheses out of that first fraction. So I'm just going to go ahead and rewrite my problem without the parentheses. That might make it a little bit easier. So I've got 1 minus x minus h all over 2 plus x plus h minus 1 minus x over 2 plus x all over h. I know that if I want to divide fractions, I have to have a common denominator in my numerator. So to find my common denominator, I'm going to multiply the first fraction by what it's missing, which is a 2 plus x and a 2 plus x. I have to multiply my second fraction by what it's missing, 2 plus x plus h, and 2 plus x plus h. So we've got ourselves a lot of distributing to do. So let's go ahead and take a few minutes to go ahead and do that. So I'm going to have my derivative is equal to the limit as h approaches 0 of, so I've got my common denominator in my numerator of 2 plus x times 2 plus x plus h. And that, of course, is all over h. Probably have to make this bar a little bigger here. So now, in my first fraction, I need to distribute the 2, and then I need to distribute the x. So that's going to give me a 2 minus 2x minus 2h when I distribute the 2. Now let's distribute the x. That's going to give me an x minus x squared minus xh. Then I've got a negative out in front, and I want to do the same thing for my second fraction. I want to distribute the 1 and distribute the negative x. So I'm going to have a 2 plus x plus h, and then a minus 2x minus x squared minus xh. So now, as we take a look at this, I want to distribute that negative to everybody in that second set of parentheses. So let's just go ahead and put that right above here. So that's going to become a negative 2 minus x minus h plus 2x plus x squared plus xh. So now I can take a look and see what can cancel out. So I've got that my derivative is equal to the limit as h approaches 0 of, well, my 2's are going to cancel. My negative 2x cancels with my positive 2x. My x's are going to cancel. My x squareds are going to cancel. My negative xh cancels with my positive xh. And I'm just left in the numerator with a negative 2h and a negative h. So that's going to give me a negative 3h over my LCD of 2 plus x times 2 plus x plus h. And if we're dividing that by h, that means I'm going to change my sign of multiplication and flip over my h to become 1 over h. So my h's cancel, and now I can go ahead and plug that 0 in, and I no longer have a denominator of 0. So I'm going to have a limit or a derivative of negative 3 over, I have a 2 plus x and a 2 plus x, which is going to be a 2 plus x quantity squared. If I take a look at the domain of my original and the domain of my new f prime of x, my domain for both of them is that my x cannot be equal to negative 2. So I can go ahead and say that my domain for both f and the derivative is going to be that x cannot be equal to a negative 2. Now let's take a look at what the graph of a derivative might look like. So if I take a look at the graph of my function f is given in figure 1. We want to use it to sketch the graph of the derivative. So let's take a look at what our derivative would be at certain values. Remember, the derivative is the slope of my curve. So let's take a look at where the slope of the curve is going to be 0. So if I think about where the slope of the curve is going to be 0, then the slope of the curve is going to be 0 wherever I change direction. So if I take a look at my little maximums and minimums, if I draw my slope of my tangent or the slope of my curve in, it's a horizontal line. So that means that my slope is going to be 0 here, is going to be 0 here, and is going to be 0 here. So if I want to graph my f prime of x for each x, so here's my output, and I look at where my x values were. So I'm going to have an x coordinate of 1, maybe here's 2, 3, kind of 4, 2, 3, 4. I know my derivative is going to have a value of 0 any place where my original curve changed direction. So it looks like that when my x coordinate is maybe 1/2, I have a derivative of 0. And then maybe it looks like at 1.5, I change directions again, so the value of my derivative would be 0. And then maybe here at 3-ish, I have a derivative of 0. Now let's take a look at the slope of our curve where it is negative, so going down. So I can see that my slope is negative here. It's also negative here, and then the other ones are positive. Well, if I look at the difference between these, and I'm going to call this when my x is 0, and then it looks like when my x is 2. It's a lot less steep when my x is 0 versus when my x is 2. So when my x is 0, maybe I can call that a slope of negative 1, versus when my x is 2, I can call that a slope of negative 2. So maybe here I'm at negative 1, here at an x coordinate of 2, I'm at negative 2. Now let's take a look at where my slope is positive. So I've got a positive slope here, then we've got a positive slope here, and a positive slope here. If I could look at a comparison of those 3 spots, then the first one, maybe we call that a positive 1. Down in between 3 and 4, it's a little bit flatter, so maybe we call that a 1/2. Then after 4, it's a little steeper, maybe we call that a 2. So when my x coordinate is 1, it looks like my slope was maybe a 1. In between 3 and 4, it looks like it was maybe 1/2. After 4, it looks like it was up at 2. So once I have these in, then I can go ahead and kind of connect the dots here and get an idea of maybe what my derivative would look like. So just kind of getting used to the idea of if I'm looking at an f of x, a curve, looking at the slope of the curve, where is it positive, where is it negative, where is it 0? Then you can go ahead and take a few minutes and read through the other notations. Notice we have all different ways to describe the derivative. F prime of x, y prime, d of y over d of x, d of f over d of x. All of these are different ways of saying, hey, find the derivative. A function can fail to be differentiable if I'm at a corner, if it's discontinuous, which is why our section 2.5 was so important, or if our vertical line is tangent. because we know that if I have a vertical line that's tangent, my slope does not exist. So those are the three places where a function can fail to be able to have a derivative.